Okay, pause and read the problem here. Okay, we're going to have to use a little bit of deduction here to think about this. We've got some quadratic cost function. I want to minimize it. I'm actually looking for the global minimum here. How do I know it's going to be a global minimum? Because I've taken college algebra and I know that this is a parabola that points up. I know we're going to have something that looks like that. Now, it's probably not, you're probably never going to have a negative cost. So if we think a little more, we'll realize we'll probably have something that looks like that. We also know, by the way, that you can't produce negative. X here is how many cell phones we're producing. So none of this will be in my domain of interest. We're going to have something that looks like this. So my domain of interest here is going to be 0 to infinity. Now, this is not a bounded closed interval, so the extreme value theorem doesn't apply. The extreme value theorem doesn't guarantee us a global minimum, but the picture does. It's a parabola. It's a parabola that points up. You know it's going to have a minimum value. You even know where it is. You know it's at the vertex. You know how to find the vertex. You know the x-coordinate of the vertex is opposite of b over twice a. You know this. There's b, there's a. 1200 over 2, 600. So 600,000 cell phones is when we minimize cost. We're done. This is the college algebra problem. I would put this same problem on my college algebra tests. You know the minimum of a parabola occurs at a vertex. Let's do it using calculus. We know minima occur at critical values. Those are when the derivative equals 0 or is undefined. This guy's derivative is always going to be defined. Let's find his derivative, 2x minus 1200. I wrote 12,000. Equals 0. 2x equals 1200. X is 600. Oh my God, we got the same value. Of course we did. That's where this formula comes from. That's how we know that the vertex is at negative b over 2a. We just take the derivative of a standard quadratic. So word problems have word answers. We would say that cost is minimized when we sell or produce 600,000, because X is in thousands, phones. What would that minimum be? Well, we got to plug. It doesn't ask for it. It doesn't say find the minimum cost, but we could plug it in and find the minimum cost, and that would be probably in dollars. Yeah, cost is in dollars. Okay, let's do one more. Again, this is the college algebra problem. I would put these exact same problem, like literally the same way it looks on a college algebra test. We get a ball, we throw it in the air. We want to know what's the maximum height? What's the time it takes until it reaches its maximum height? We know the vertex is at x equals opposite of b over twice a. We know we've got some parabola. There's our initial amount right there. It's at 5. Over here, it's going to hit the ground. None of this will even exist. We want that time right there. Here's time versus height. Look, it's a college algebra problem. We won't call it X here. We'll call it T. So that time will be negative 60 over twice, negative 4.9. And we could plug that in our calculator. Or we could do this using calculus. That's the class we're taking, right? H prime, the derivative. will be negative 9.8 t plus 60. Set that equal to 0. You get t equals negative 60 over negative 9.8, which is exactly what we got there. Negatives cancel. .12 seconds. That's the time. That's how long it takes until the ball is at its maximum height. The maximum height is what's the actual maximum height. We'd have to plug that in. H of that time. So negative 4.9 times t squared plus 60 times t plus the 5 right there. Here, I'll go ahead and plug that in. I'm going to do second answer squared plus 60 times second answer plus 5. 188.67. Meters. Okay, just for like realism here, ain't nobody in the world got an arm like that. Nobody is throwing a ball 188 meters in the air. A meter is about 3 feet. I mean, we're talking 550, almost 600 feet in the air. Nobody's going to throw a ball in the air that high. Okay, so that is not a realistic answer. Okay, this also has an initial velocity. That's what that number right there is. That's your initial velocity. That's your acceleration over 2. Nobody's going to throw a ball at 60 meters per second. That would be like 180 miles per hour. But that's okay. Stop that.